I'm Jonathan Brendefur, and I'm going to be talking about exponents today. So earlier, you might have been watching Sam. He talked about the rule of 10, powers of 10. And so that is a fifth grade standard typically in the United States. And I'm going to talk about how you extend that into middle school, get an understanding of exponents so that you could use them correctly and symbolically later on in higher levels of mathematics. But what are exponents? So I'm going to take an example of 3. What we typically say is 3 to the second power. The 3 is the base, which is the number or the amount that we're going to start with. 2 is the exponent. It's a superscript, so it's a smaller digit or number that's above the base number. And that is going to tell me how many times I'm going to take the base and multiply it by itself. So the exponent is very useful. The entire term, so the term 3 squared is typically considered the power. And many times we'll talk about this as this is 3 to the power of 2. So let's talk about what that actually means though. So if we start with a base of 3. So here is, and we can talk about this as a unit. So we're going to talk about this as our unit of 3. And we would represent this as 3 to the first power, saying that the 1 represents that we're just going to have the 3 by itself. Multiply it. Now, if I said, so I'll write this down here, 3 to the first power is equal to 3. Now, what is 3 to the second? How would you describe that? What would that look like linearly? So if you have a class right now, pause for a minute and extend this bar model out. What would that look like? Okay. So 3 to the second power is going to tell us we're going to take that base and we're going to multiply it by itself. That means we're going to have 3 iterations of 3. So a lot of times we'll talk about this as iterations or copies of that base unit. So many times we talk about this first one as 3 iterations of the base 3. So here's the 3, and I'm going to take 1 copy, 2 copies, 3 copies. So that's 3, 6, 9. So 3 to the second power would be here. Okay, now, continuing that process, what would 3 to the third be? So again, if you're working with students, take a pause here and extend it out. What would that look like? Okay, in this case, again, we're going to have 3 iterations, but this time it's of the previous unit. I'm going to take 3 iterations of 3 times 3, or 3 to the second power. So that means I'm going to take the 9, and I'm going to iterate it, the 1, 2, 3. So now I'm at 9, 18, 27. So 3 to the third power is now we have the 3 iterations of 9. Finish these up here, so that's 27. Now if I was to do that again, 3 to the fourth, where would 3 to the fourth be? If we use that same idea, it's 3 iterations of 3 to the third, or 3 times 3 times 3. So now I'm going to take the 27, and I'm going to iterate it 1, 2, 3 more times, and I'll be much farther out, which will be 81. So that gets a sense of how we're building the exponent to create those powers and to build it exponentially out. Let's reverse the process though. So the other way of talking about, instead of iterations or copies, we can also talk about partitioning or splitting it evenly. So if I go back to 3 to the third, it's saying 27, and now I need to partition that into my base, partition to 3 equal sections, 1, 2, 3. Where am I? I'm at 3 squared, or 9. Let's take 9 and partition that into 3 equal sections. I'm back to 3. 3 to the first. Now, if I was to continue that, and I'm going to use a different color here. If I was to partition the unit of 3 into 3 equal sections, where would I be? Right here. That is 2, 1. So 3, that's called 3 to the 0. So 3 to the 0 power, you're back at 1. So whatever your base is, it's going to divide or partition that back into the same amount of pieces, so you're always at 1, which brings us to why is 3 to the 0 always 1? Because you're always partitioning whatever base unit by that same number. Now, if we continue that process, we're going to partition the 1 into 3 smaller sections. So now, where am I? That is considered 3 to the negative 1. So now I'm partitioning the unit of 1 by that base into 3 smaller, and I'm at 1/3. So 3 to the negative 1. So the negative exponent doesn't mean we're in negative numbers. It just means I'm partitioning smaller than 1 now. So if I was to do that again, what is 3 to the negative 2nd power? That means I'm taking the 3rd, and I'm partitioning that into 3. So that's 3 of the 3rds. So what is a 3rd of a 3rd? That would be 1/9. So that gives us a linear model of exponential functions, or exponential exponents, excuse me. You get a sense of how it, using iteration, grows, but then also partitions by that same base to make it smaller and smaller. So when you have a base that's a large negative exponent, it just means it's a very, very small unit compared to 1, not into the negative numbers. So hopefully that gives you a sense of conceptually what are exponents.